Welcome back to another video, everyone. So today we're just going to be having a quick look at where the Pythagorean identity of sine squared x plus cos squared x equals 1, where does that actually come from? Because I do know that a lot of teachers, unfortunately, will just tell you to memorize this identity, and then that's the last thing that they'll say about it, and they'll just say, use this to answer some questions. But it is quite important that we understand where it comes from. And so it's a relatively simple derivation. So all we need to know is that we need to know Pythagoras' theorem, so a squared plus b squared equals c squared, and that of course is for the right angle triangle where c is the hypotenuse and a and b are the other side lengths. The order of a and b doesn't matter at all. And the other part that we do need to know is we need to be able to quickly define sine of x as the ratio of the opposite side length over the hypotenuse. And similarly, we should be able to identify cos of x as the ratio of the adjacent side length over the hypotenuse. If we know these three facts, then we can very quickly derive this identity here. So let's get into it. I'm just going to go ahead and quickly start with the unit circle. So that is the circle centered at the origin with a radius of 1. I'm now going to go ahead and quickly construct a right angle triangle inside this unit circle. So that now means that my hypotenuse length must be 1. Okay, so let's go ahead and label this angle here x. Now, if I'm interested in finding out the length of this horizontal displacement here, how would I do that? Well, since it's a right angle triangle, I would use the fact that cos of x equals the adjacent over the hypotenuse. But we know that the hypotenuse is 1, so I can then just go ahead and rewrite this in as cos of x equals the adjacent, or in other words, this length down the bottom here is simply cos of x. And we can go ahead and really quickly do the exact same thing for sine of x, right? So that will help us find this vertical displacement here. So sine of x equals the opposite over the hypotenuse, and once again, that hypotenuse value is simply going to be 1. So that now means that our vertical displacement is simply sine of x. Okay, so now we can go ahead and plug those values into Pythagoras' theorem, and we'll end up with cos squared x plus sine squared x equals 1 squared. And we know that 1 squared, well, that simply equals 1. And there we go. So that is the Pythagorean identity in its most basic form. And now you might be thinking, well, that's all good and well, but what about for the situation where we don't actually have the unit circle itself? So let's say that we have another circle with some unknown radius. I'm just going to go ahead and quickly call this r. Okay, so with that in mind, let's quickly go back a moment. And again, we won't need to know anything else apart from sine of x, cos of x, and the Pythagorean identity, Pythagorean theorem, I should say. And we can go ahead and quickly find out what are these side lengths going to be. All right, so again, if we wanted to work out the horizontal displacement, we would quickly need to find some expression for this horizontal distance down the bottom. And again, quickly calling this angle x. So now I can say that cos of x equals, I'm just going to label it adjacent over the hypotenuse, which is r. Okay, so that now means that the adjacent side length is equal to r cos of x. Similarly, for our vertical displacement, I'll be able to say that sine of x equals opposite over the hypotenuse with a length of r. So therefore, the opposite side length, I'll quickly just label that adjacent and opposite, must be equal to r sine of x. And once again, if I plug these values now for the adjacent side length and the opposite side length into Pythagoras' theorem, let's see what we get. So it would now become r squared cos squared x plus r squared sine squared x equals to the hypotenuse squared, right? So that would be r squared. And what you'll see is that everything has that factor of r squared. So we can simply remove that factor. And what are we left with? Once more, cos squared x plus sine squared x equals 1, as required. And there you are. So if you have found today's video useful, please leave a like and subscribe, and do let me know if there's any other topics or problems that you'd like to see me work through. Hope you have a great day, and I'll see you next time.